Hello and welcome to this webinar. Make your apps scalable and web-enabled. Leverage your business logic with a fast, flexible, multi-tier architecture using RAD Server and REST services. The replay, slides, and resources for this webinar will be available at the URL you see on the screen, embt.co/webinar-scalable 2018. For quality purposes, all lines except the presenter are muted, but it's okay to ask questions. Use the Q&A panel on the right. It'll be recorded for playback later. If you're here for the live session, you will be able to participate in the live Q&A part. Otherwise, you can access the Q&A log at the replay link. My name is Jim McKeeth. I'm Chief Developer Advocate and Engineer for Embarcadero Technologies, and I'll be your presenter today. Our agenda, we're going to talk about the monolithic problem, which is where a lot of our applications either started at or are right now. Then we'll look at some architecture types and talk about why scalability is important. Then we'll look at how microservices compare to monolithic services, making your business logic scalable. Then we're going to take a look at the Field Services RAD Server template, which is a recent template we released that shows how to implement your application using RAD services to be more scalable. And we will also show how you can use XJS, Sencha Ext JS, to web enable your RAD server based application. And finally, we're going to look at some of the different editions of RAD Studio just so everybody knows which version is right for them. The monolithic problem. The monolith is an application that does everything in one tightly coupled module. All the UI, logic, data, etc. is all in there together. It's really easy to start building your application this way. You just start dragging, dropping components, double-clicking on things, setting things up, etc. Oftentimes your data access components are on the same form as your UI elements, things like this. It's all just in there together. Like I said, it's really easy to get started this way, but what happens is it doesn't scale well. Over time, as the application continues to grow and get more complicated, it's harder to maintain it, it's harder to debug it, and then when it comes time that you have concerns about scalability, moving to other platforms, etc., it becomes obvious this isn't a sustainable solution. What does coupling mean? I talked about coupling there. Coupling is the degree of interdependence between software modules. So when something's tightly coupled, a change in one of the modules ripples effects through all the other modules. Adding and removing a module or part of the software is very complicated because everything touches everything, right? So it's, you reach in and grab one thing and it just sends ripples everywhere, and it's all the interconnection just makes it more difficult to maintain, and you can't take any modules out and use them in other applications, plus you can't test things, etc. because of all this interdependence. Loosely coupling is characterized by well-defined and limited interactions. Kind of diagram down at the bottom kind of shows tightly coupled, everything's kind of overlapping, it's just kind of a big puzzle. Where loosely coupled, you have less coordination, less information flow, less interdependency. This diagram kind of shows what some different degrees in here might look like. The monolithic application on the left is where everything, your data storage, your UI, etc., is all in one application. Now, even within your application, you may not even have these well-defined areas within the application. Like I said, you might have your data access controls on your form that has a user interface on it, for example. And that would be an example of everything being mixed up together. And so you really wouldn't even have these separate parts within your application. It's just all there together. Like I said, that's great for small applications, great to get going. But eventually, you want to start moving towards the right as you start to run into maintainability and scalability and performance issues. So the next level there is the client server. The client server is where your data storage is separate. It's on a separate server. So this is where you have a database like Oracle or Microsoft SQL Server or MongoDB that's hosted elsewhere, and then all these client applications talk to that database. So in the monolithic application, since the data storage is within the application, multiple users can't access the same data at the same time. Okay, this is the desktop model. The client server, though, you have a shared data storage. So the applications can share that data storage between multiple applications so users can interact and share their data. Then we start to move towards the multi-tier applications. So multi-tier applications is where parts of the data model and the view model and the business logic is also hosted outside of the main application. So in order to make this progression to the right, though, it's important that within your application, you also have these parts in their own areas, right? So this is where you're going to be taking advantage of data modules to hold your database access components, for example. And beyond that, actually, if your application is complicated enough, you might have multiple data modules that are associated with different data access, right? So if you have a very large application, you don't want to have all of your data access components on one data module, because you probably don't need to have all your data access in memory at once, right? So by splitting it apart into multiple data modules, you're able to segment that across concerns as well as across use types. So the final on the right is the microservices there. Microservices is the idea of where you've taken not only the vertical services separated, right? So where we're separating out data storage and data module and business logic, but also the domains. So for example, you have a service that's related to, or data storage that's related to authenticating users. That can be separate from the data storage and the services related to inventory. Okay, so you're separating it both horizontally and vertically. Kind of how I think about what microservices work. Microservices are hot right now, but you don't start with microservices. I'm going to talk about this a little bit. Generally, you're going to start on the left and move towards the right. But it's important to think about that these architectural differences, because as you're making these moves to the right, the more you can plan ahead for that, the better. Now, don't start at the right, because you might split something apart that you don't need split apart, and there's a little bit of overhead in that and having things separated. So what you want to do is, as you run into performance issues and scalability issues, you start moving towards the right. Scalability is more important as you grow. It means you're able to service more users or more workload at the same cost per user and workload. And how this is accomplished is through horizontal scaling. So the difference between horizontal and vertical scaling, and this is a hardware-related term, whereas before I was talking about horizontal and vertical services and architecture. But with hardware scaling, vertical scaling is where you have to use a more powerful and therefore more expensive server. And this works with all software. So for example, years ago, I worked at a company and we had a desktop application that was the example of the monolithic application. Everything was in one application. And they just have to as the projects got more and more complicated over time that they're working on, they had to keep buying bigger and bigger and bigger machines. Pretty soon the machine they had was just crazy, the amount of power it had to have to handle this application, because the application had to run on one machine. Okay. Horizontal scaling is where you have your application, the multi-tier application or the remote data storage, where you can have parts of the application running on different machines. And so this allows you to just add more commodity servers as opposed to huge beefy servers that are lower cost per power, if you will. So the total processing power, storage, etc., is cheaper in horizontal scaling per unit than in vertical scaling. Now, the difference is vertical scaling, like I said, works for most software, whereas horizontal scaling requires some architectural changes. And this is, I've alluded to this earlier, but there's a great article by Martin Fowler. The link's down there in the lower right corner, called Monolith First. And basically the idea is, and you look at this diagram here, is going directly to microservices architecture is risky. And really it's risky because of YAGNI, Y-A-G-N-I, you ain't gonna need it. When you go down the microservices route, and you're like, oh, well, we'll split out by departmental organizations, right? And you're like, okay, everything's split out this way because that's what I think we should do because we're doing microservices. And there's a little overhead in microservices every time you split things apart. But then the problem is that you realize, oh, all of these other microservices I split out really have very little workload, right? So there's no performance concerns around that. But this one part here that's inventory, for example, inventory, oh my goodness, it is so complicated. There is so much workload in the inventory service that it's the bottleneck, right? And so then you got to go in and start ripping and splitting apart inventory based on different types of inventory or whatever makes sense in your use case, right? And so that's the key, is that you start with the monolith. And then as complexity rises and those performance bottlenecks start to show themselves, that's when you start breaking things apart into multi-tier microservices. What this does is allows you to get to market quickly and then scale over time and make those refactoring architectural changes over time. So with RAD Server, when you're wanting to move your monolithic application into a multi-tier scalable application with RAD Server, what you'll do is RAD Server uses data modules behind the scenes to contain the business logic and the data access. And so you just refactor your code into loosely coupled data modules, move the data modules for data access into RAD Server, and then you make remote calls to RAD Server to access those data modules to give access to your application. Nick Hodges wrote a blog post called the RAD Server Story, where he talks about doing exactly that and how it gave an application the ability to scale and work better, perform better over the long run. One thing about this, though, is latency issues. I had an interesting experience years ago where we did this. We moved from a client-server application to a multi-tier application. And we had a use case where a user was using the application over satellite internet. Now, satellite internet is not very common anymore because broadband is becoming, broadband like cable internet or DSL is becoming more and more prevalent. But this one use case user was connecting over satellite. Now, satellite has a really fast download, but a really slow ping time. Okay, because of the distance traveled. Now, anytime the distance traveled goes up, your ping time goes up. That's just the way it works. Now, well, there are caveats to that, but generally speaking, that's a good rule of thumb. So if you're moving from a local data storage or local data module to a remote data module, even if it's on a machine just next to the machine you're on or on a machine in the cloud, that latency is going to be higher. And so what you want to do is you want to think about how you're interacting with things, doing things like having local caches instead of repeatedly getting the information, right? So if the data module, if the data storage is within your application, right, every time the user scrolls in the list, we'll just keep reloading it from the data source, right? No big deal. But if all of a sudden, right, so when it goes off the screen, you take it out of memory. But if that data module, if the data storage is in our database or in a remote database, then that going and hitting it each time the user scrolls is going to be really tediously slow, because each time a new line shows up, you go and hit the database and pull it back. New line shows up, hit the database, pull it back, right? Now, that seems like a really obvious to us, right? Because we know, hey, keep your data, your list, your grid in memory. But it's an example of the kind of latency issues you can run into. So that's where you want to use caching. Think about, right, if you have a series of queries you're doing that aren't dependent on each other, run them parallel, right? See if you can batch them up. FireDAC has a number of incredibly powerful features to let you do batch queries. So you can, like the array DML, for example. So proper architecture can prevent latency issues. So kind of want to be thinking about that as you're doing the refactoring. You know, how am I going to be making these calls? How am I going to be interacting between those different tiers, different services? And what can I do to prevent these latency issues? And you can actually, I've had lots of experiences where something was kind of slow, but it wasn't a big deal. It was usable, right? And then all of a sudden we had to deal with that latency getting larger because we moved it to a like the satellite situation or whatever. And so we're like, oh, well, we go and look at it. And we're like, oh, well, this is clearly poorly architected. And so we switched to either bundling things up or running things in parallel, whatever the case may be. And it actually improved the performance, right? And so this is where it makes some of those bottlenecks obvious when you have to deal with this. And then when you go in and fix it, it actually can be faster. So just because you're dealing with a higher ping time doesn't mean your application is going to get slower if you architect it properly. Now, if you don't architect it properly, yeah, it's going to get slower. But architecting it properly can actually make it faster. So let's kind of go through a little example here of what this might look like. You have your existing monolith, and it's time to migrate it to make it scalable. So you start with your data storage, okay? Instead of storing all your data in memory, you're instead going to store it on a remote client server database like Oracle, Interbase, SQL Server, etc. FireDAC is a fantastic framework. There's lots of other third-party ones out there, but you might as well use FireDAC. It comes with it, unless there's a specific situation to use this third-party ones. So once you have your data storage on a remote database, then you want to isolate all the database calls into a dedicated data module. This could be multiple dedicated data modules, but the idea is that all the data calls that deal with the data model, should be isolated and not sprinkled throughout the application. Next, you want to isolate the business logic. So all the business logic, which is the rules about data. A classic example of this could be an email address, right? So rules about what an email address looks like. So in the database, you might not, it's just a string, but your business rules, business logic might say what an email address has to look like. Or rules about how data can be changed. So the data model would be things about like this data is related to this data, for example. Whereas the business logic is like saying if you change this, then it has to produce some other changes, or the logging, so a change happens, there has to be logging, or who can change what, stuff like that. Generally, those are the rules about how the data is used, if you will. And this, again, you're not going to have one central core of business logic. You're going to have business logic related to the different areas, okay? So it's about isolating the business logic. It's not about consolidating the business logic, if that makes sense. So now we look at the view model. The view model is how the UI and the business logic, or the data model connect, okay? So this was what connects the data model, the data, and the UI. Again, you're going to refactor this out, isolate it in order to make it easier to maintain. So what that does is it gives you the ability to test your view model separately from your UI, because UI testing is a little more complicated, although with RANRX, it can be a whole lot easier to deal with. But it gives you the ability to separate that out, and also the ability to maybe switch to a different user interface, which we're going to talk about a little bit about later. And now, this is when you make the move to RAD Server. So you'll notice the business logic is in both the multi-tier application and the RAD server. And the reason is, and this is really important, is you don't want to have to hit the server to validate the business logic. All right? You want to be able to validate as much as you can locally, because that creates a more responsive application. But you don't want to ever assume that all the calls made to the server are following your business logic. Okay, because that's when you run into problems when somebody else comes in like, oh, I'll make my own client, right? Or maybe someone else is running an old version of the client application, and they fire it up and it's been offline for a year, and they connect and all of a sudden start doing things with it has an old business logic, old business logic in it, and then the server is not validating that business logic. Then all of a sudden things are happening that don't make any sense. There's lots of stories about that sort of thing happening, where you have some old system that's been offline that comes online, and it's totally legitimate to connect, and it has, all the credentials, but the problem is it's out of date, and that business logic's not being enforced. So you want to have your business logic in both places. Now, you can usually do this by just including those data modules in both places, and not all business logic makes sense to enforce in both places. Some of your business logic actually might exist in your data storage, in your database, right? By triggers and stored procedures and stuff like that. But the point is that you can share these data modules between RAD server and your application, and you need to have your business logic in both places. So you might as well share that business logic data module between both places. So again, let's talk about microservices. So it's not just about the horizontal separations, but it's about the vertical separations here. So you see we have 4 different data stores, right? We have a customer data store, invoice data store, inventory data store, and user data store. But then we have 3 different services. So the inventory and invoice service, because there's a relation between those, we decided to create one service that deals with both those data sources. Okay? And then we have a customer service and an authentication service. Then our users, maybe their applications they're using are different. So the customers, they don't ever need to talk to inventory and invoice except through their customer module, right? So they talk to the customer service, and the customer service then in turn talks to the inventory and invoice service. Where the warehouse worker, they don't care about customers. Well, I mean, they do, but they're not interacting with the customer service. Instead, they're interacting with the inventory service, part of the inventory and invoice services. Everybody has to go through authentication to control user access. All right, so this is a simplified example, but one of the points I wanted to make is that you can have your services don't have to align up with your data stores necessarily, and oftentimes you're going to have multiple layers of services, right? So you might have another service that handles inventory that sits behind the invoice and inventory service, right? And so the invoice inventory service talks to that service, which then talks to the data storage. Sometimes these services talk to multiple data stores, sometimes they don't. So it's just a matter of what fits for your scenario. And again, where your performance bottlenecks are, right? Where do you need to scale? Where do you need to break things apart for the performance to be better? You're going to start with those bottlenecks and break them apart. And generally, that's the rule of thumb. Again, think about the overall architecture as well. For example, authentication is a great example of something that you could separate out, because the users maybe hit it once, right, when they're first connecting, and then you get that token, and then the token is just used throughout the system. So some of it's based on architecture, some of it's based on performance bottlenecks, but generally performance bottlenecks should be your guiding factor in how you're going to refactor this to microservices. All right, let's take a look at the RAD Server Field Services template. This is a template application that was created to show how you might reuse RAD Server to create a field services application. It's available through Get. It's a template that you can use as a base to build your own solutions. It includes a number of different modules, the field services app, which is designed to run on mobile or desktop, the admin, which is a desktop application is used to administer it behind the scenes, the server, which uses RAD Server, and then there's a setup program you run once that just sets everything up for you. Full source code and graphic resources are available. It's written in Delphi, although all the technology works fine in C++ Builder as well. There's a very detailed documentation and then a number of videos, which I have a link to a playlist for you at the end here as well, that walk you through the different parts of it. So you can understand how it all works and how to use it. It's a great resource for learning about REST services in RAD Server, or like I said, it can be used as a template to build your own solution. Okay, so what about web enablement? I kind of mentioned this at the beginning. Chances are on this webinar, you are a native application developer. You appreciate the power and performance you get from native applications, but sometimes you want to have a web-enabled interface. And this can provide a minimal friction for new users to connect to your application, right? It's also compatible across more devices and platforms. If somebody is running on Solaris, for example, and you don't have to worry about writing a Solaris client. They've got Chrome on Solaris. Maybe, I don't know if there's Chrome on Solaris or Firefox or something like that, right? They connect with a standard browser, boom, they're on your application. Doesn't matter what platform they're on. So you're trading off some performance and features from a native app to give you this greater reach. It's also because there's no installation. Let's say, for example, one of your users that has your application installed on their desktop at home and on their mobile device, they're in the library, for example, and they don't have access to their computer, but they need to get onto your application to do something. They can use the web interface. Also, it's an on-ramp for new users to move them to the native experience, right? So they come on, they're using the web interface, and they're like, oh, this is great. And you're like, well, if you use the native experience, you get access to more features. And they're like, okay, well, clearly I need to do that. And they will move into the web native experience. So let's do a quick demonstration for you, showing you how some of these parts work and what you can do with them. The Field Services app template is available through Get It here. It's under the Industry Templates category, which you can see there's a few other ones here as well. And I will point out that the Hospitality template has a Ext.js web interface as well. So you can take a look at that to see that in action as well. But once you've installed this, you'll find it. It's actually in your samples folder here. Just go here to this. So it's in your public documents, Embarcadero Studio 19 samples. So in your samples folder, all the other samples are industry templates, Object Pascal. Like I said, it's written in Object Pascal, but it works. All the technologies and stuff work with C++, so you can certainly re-implement this in C++. In here, you're going to find two PDFs. The Quick Start Guide, which is just a few pages on how to get up and get going quickly. And then the technical documentation, which is much more in-depth about how this works, architectural overview, and the different parts and pieces, table configuration, stuff like that. 40 pages of this, so plenty of reading for you. First thing you're going to do, though, is run the setup. I'm not going to go through this a whole lot of detail, just kind of give you the overall overview of it, because the videos do a much better job explaining it than I do, and I don't want to repeat everything that's available in those videos and the documentation. But you're going to run the setup, run through this. Once you're going to already have EMS server set up, which is covered in DocWiki and running, and then this sets up the database and everything you need, all the users and stuff like that. Next thing you do is run the server. So the server is the part that's going to run inside of RAD Server. So this is it's a BPL, and I can go ahead and run this now because I don't have RAD Server running. And we see here it's loaded the INI file, and that you use, this is what configures it. Here's the EMS server interface instance, and right there is the BPL. So the Field Services server is BPL. This is the development server. There's information in the DocWiki on how you would deploy EMS into production, RAD server into production. But now this is running, so you can connect to it via the server, the admin application, or the client application. So let's close these. And nope, I'm not making a new project group. And we'll look at the admin app, which is right here. So the admin app is designed to run on Windows. To administer it, it's got a lot of different parts to it here. One note I'll tell you that I figured out is because some of these frames have the same name in between the admin app and the client application, you don't want to have them both in the same project group, because if you have them both open at the same time, the IDE, it gets weird when you're switching between frames, and sometimes the IDE gets confused about which frame goes with what. So Don't do that. And then lastly, here is your app, which you can then run on Windows, or it's designed specifically for mobile devices. That's it. So, once you've installed it, come in here and find it in your templates or samples folder, industry templates, Object Pascal, field services, RAD Server field services demo. Show how to do an EMS front end or a XJS front end. So I've created a really simple application here, a RAD Server module. Walk you through the steps here. I went in here to FireDAC and Interbase in the Data Explorer and put a couple tables down, or put the table down, the employee table down, which is right there. And then I put down the batch move component, batch move dataset reader, which points to the employee table, and a JSON writer, which is the new component we added for the purposes of making it easier to create the JSON you need for connecting XJS clients to it. The code here is not that complicated. The only thing I've really implemented is the data source, the GIP process here. And all it does is uses the batch writer to write it to the body. That's it. So we just tell the JSON writer where to write it into the body and make the batch move. And what that's going to do is going to grab all the data from the employees table and write it into the body. So let's go ahead and run this. And I'm going to open the browser. And if I come in here and say employee, there's the JSON that comes back with all the employees in it. Now, because I've come in here and modified my EMS server to have a, so I can move this up here at the top so it's easier to see. The EMS server INI, I've pointed it to this Sencha Ext JS folder, which contains some a JavaScript file and HTML file to display this data. So the HTML file here, which I'll give you this, it's actually, I should put a link to where it caught it from. It's from a sample that's included with XJS. You can use it either pointing it to the samples online, although the fonts won't load if you do that, or if you install XJS locally, then you need to set up another path here to the folder where that's at, which in my case is web, which is right here. And then here's the XJS 660 folder that contains all of XJS in it. So point it to there, and then it will load everything, all the libraries and style sheets and fonts and stuff like that it needs from there. So if you don't have it installed locally, just switch to these online versions. Just know that the fonts won't load properly. And then here is the JavaScript that does this. And so if you're wanting to build off of this, I'll just give you a quick overview of what's going on here. Here is the data module. So these are the 4 fields we're dealing with: employee number, first name, last name, phone extension. And right here is the URL to the endpoint. So if we go to the browser, see, localhost 8080 employee. Although I guess I could take that off there and just make it employee. Let's try that and see. All right. Nothing like trying it in while I'm recording, right? And then down here is where we bind the data to the grid. So these are the columns of the grid. I have an ID column, first, last, phone extension, and the data index is the name of the field that's included there. See, last name, last name. That's it. Pretty straightforward. Tons more documentation available from Sencha website on XJS, and you can see it from there. So this is the page. I'll just go ahead and reload this now and see if I broke it with my change I just made, right? I didn't break it. Yay. So content is, so we'll take a look here. I have the content folder, the path, content path points to this folder, right? Users gem desktop Sencha Ext JS, users gem desktop Sencha Ext JS, and then I loaded the restful.html, and that loaded this in here. Here's the JavaScript that runs behind the scenes. And there's the data that's being pulled out of my database, out of my REST server, which is in a interbase database. There's data there. I didn't implement the add and delete. You can click on those. They won't actually, if I delete, it actually deletes a local copy, but it sends a post to the server. And if we look here, we can see that it sent the delete item to the server, but I didn't implement that just for simplicity's sake. You are more than welcome to implement that yourself if you would like to. Interestingly, for some reason, it doesn't load this font. So you see there's an error here. Wasn't able to load this font. I'm not sure why. It appears to be there, but it doesn't seem to be noticeable in the UI. The font, if you don't have the font loaded, you'll notice these things disappear because these are loaded as font files. A few of the little things you'll see disappeared. So there you go. That's it. That's a quick, simple example of how you use XJS to build a web front end to your RAD server and to web enable your application. For the web interface, we used Sencha Ext JS. XJS is a framework by Sencha that's owned by our IDERA shared parent company that helps you build data-intensive web applications. It uses JavaScript, HTML, and CSS. One thing, if you're coming from Delphi C++ Builder, you're going to love the fact it includes all these components, 115 plus UI components, including calendars, grids, charts, pivot grids, and more. Unigui, for example, is a third-party tech partner of ours that combines these together so that you can have the Delphi-like experience of dragging and dropping these components on a form, and it builds a XJS application from that. One note, there's two flavors of XJS. There's classic and modern. Now, in the past, there was XJS and Sencha Touch. Sencha Touch got rolled into XJS and became what's known as what's called modern, whereas classic was the existing XJS. Now, generally speaking, they're kind of moving towards merging, but right now, classic is more focused on desktop and greater compatibility on older browsers. For example, older Internet Explorer. So if you're working in a corporate environment and you got, the corporate standard is old versions of IE, which I don't know why that still happens, but it is, then classic's probably what you're going to want to use. Whereas modern is focused on more modern standards, mobile devices, and it's not that classic's no longer being developed, but they're both being developed, but the modern is more focused on modern browsers. So if you want to take advantage of modern browser features, but realize you're not going to work on old versions of IE, then modern works, right? Modern is designed for mobile applications. But there's also a universal application. And universal applications uses both modern and classic behind the scenes so that when you're running on IE 8, it switches to classic. When you're running on a mobile device, it switches to modern. And so it actually gives you the best of both worlds. For more information on Sencha, you can check out sencha.com/products-xjs. EXTJS is pronounced XJS. Docs.sencha.com, that link there shows you the REST proxy, which is what we used to connect to the REST service to the grid. And then that example down there at the bottom, the last link, is the space source code that I used to build the example that I showed you today, talking to RAD Server. A couple notes about using RAD Server with XJS. In Tokyo 10.22, a new FireDAC component, the TFD batch move JSON writer component, was added, which generates the JSON for XJS and actually for any client. It actually makes it really easy to generate that JSON. It properly formats the JSON and actually significantly improves the amount of code, reduces the amount of code you have to write, and improves your experience developing in general as well. So it's a great addition. And 10.2.3 Tokyo, the RAD server was expanded to allow you to host static files. They're called RAD server file dispatch support. And what this does is you can add the EMS INI file and add a server public paths in there that lets you publish certain folders to contain files that are just published out through there. And so what this does is previously in 10.2.2, and earlier you had to use the cross-domain support in order to allow you to load these files from a separate web server. But now with the server file dispatching support, you can dispatch those files, those HTML and JavaScript and images and stuff like that through your RAD server instance, and it makes it much easier to deploy these more complex applications using, for example, XJS. Now, I wanted to talk also about some of the different editions of RAD Studio because it seems like people get confused which edition they want. I want to make sure you have the right one. Granted, you can always talk to sales, and they're great at helping you figure this out as well. So RAD Studio includes both Delphi and C++ Builder, and gives you kind of the complete platform for building multi-device native applications. Generally, there's some things that C++ is better for, some things that Delphi is better for, and with RAD Server, you can actually have that C++ and Delphi code interacting with each other and working together. So it really is, it's not just about like buying Neapolitan ice cream and giving some people chocolate and some people vanilla. It's about having that combination that allows you to mix these together and use the right language for the right scenario to create a much more powerful, much more productive situation. RAD Server targets Mac OS, or Apple's Mac OS, iOS, Android, Microsoft Windows with both 32 and 64-bit compilers. That's in professional. Okay, so professional is kind of the baseline. If you're in just Delphi or C++ Builder, you can get the Community Edition as well. But for professional development, you're going to want professional RAD Studio. Then Enterprise is everything you need for server-side development. So that's kind of the differentiation between professional and enterprise. Enterprise is all about giving you server-side development support, and it adds not only 64-bit Linux server compiler, but also the ability to connect to remote databases. Okay, so with professional, you can connect to remote local databases, but Enterprise lets you connect to remote databases. So a local database would be a database embedded in your application or running on the same machine as your application. Whereas Enterprise, or remote database, lets you connect to a machine running on another, or a database running on another machine across the network. Enterprise also gives you a RAD Server single site deployment license. So if you want to take some advantage of some of the great RAD Server features you saw today, you definitely want to take a look at least Enterprise. Now, Architect gives you, it's designed for the systems architect, right? The person that does it all, which in the past I ended up being, didn't know that's what I was doing, but I was the architect, right? You know, you're the person that has to configure the databases and do all that stuff. And that's what Architect is for. It gives you RAD Server multi-site deployment license, as well as a bundle of other fantastic features, products. Change Manager, DB Change Manager is, if you've ever in the past had to deal with making scripts to keep your databases in sync, right? So you have multiple deployed databases and you have a script that you roll out that upgrades your databases and stuff like that. I've had to do that at a number of places. The DB Change Manager fixes that for you. It lets you take a database and make it so that you can check that database into source control. I wish I'd had this years ago. It's so awesome. ER Studio, before I came to work for Embarcadero and before Embarcadero bought Delphi and C++ Builder, I was working on a company and we used ER Studio. We looked at all the different data modeling tools out there for forward engineering, reverse engineering, and building complex data models of your database, and decided ER Studio was the one to go with. And then Embarcadero bought Delphi. I'm like, hey, I know ER Studio. These are good guys. So that's ER Studio, that's what it's all about, is building these large complex data modules. In the past, people used tools like Irwin. Irwin's going away. No one uses Irwin anymore. It's all about ER Studio. Let's see, Rapid SQL, SQL editing tools, DB Optimizer helps you optimize your database performance, and I don't remember, DB Power Studio I think is stored procedures and other sort of things along that. Anyway, lots of great tools. If you're an architect, you want this package because it gives you all the tools you need to manage the database and do so much more than just building the applications. So now I'm going to give you access to information and resources. Again, That URL there, embt.co/webinar-scalable 2018, is going to have all these resources and more. There's some that just didn't really fit on the slides very well, but I like putting them in the slides so that I can talk to you about them here as well. So this is, we did a webinar last year, I think it was, with Danielle Tete from BitTime, talking about Delphi architectures, modern Delphi architectures. And he came up with this framework called Columbus Egg for Delphi. And he explained to me why the meaning behind the name, and I don't remember exactly what it is, but it's a puzzle. But the idea behind Columbus Egg is it lets you, now one of the problems is if you're a Delphi developer, C++ developer, like I said, we tend to, drop our components on the form, and we end up putting data access and business logic and everything on the same form that has our UI. Now, we know we can do things, we can separate that out, separate the business logic out, separate the data logic out, but it tends to be more of a pain to do that. Columbus Egg fixes that problem. It's really elegant how it does it. Definitely take a look at this. It's free and open source. You can find it down at Bitbucket, is the URL for it. It's really a pretty cool solution in letting you keep that all separated so that you can test your business logic and have your business logic and your data access all separated apart. So this gives you the ability to build that separation like I showed you, but still have all the great productivity benefits of the RAD style of application developments that Delphi is so famous for. Here's some resources for you on RAD Server. We have a playlist on YouTube there, which has videos on migrating to RAD Server, a deep dive on creating a department store retail solution, which goes into some of the beacon fencing and barcode scanning and stuff like that. Information on RAD Server multi-tenancy, which gives you the ability to have distinct, separate applications, multiple distinct separate applications running within one RAD Server instance. And then building a microservices architecture with RAD servers. There's other videos on there as well, but those are just some I wanted to point out for you. Marco Cantu has a blog post on building flexible and robust apps with multi-tier architecture. It's fairly recent, good stuff there. And then here's some links to the doc wiki on RAD server overview. Configuring EMS, the second link down there at the bottom. The first one is how to set up EMS server, and the second one's editing your EMS configuration. That talks about how to set up your public files that you want to serve out through there, like I showed you with the JSON and HTML. And then down at the bottom there is a case study with Foresight doing exactly what we're talking about here, right? So they had a monolithic application and they wanted to move to a more scalable solution. So that case study on YouTube talks about, it's an interview with them. They're talking about some of the challenges they faced, how they overcame them, and more. So definitely check that out if you're interested at all with what we talked about today, in order to know more about how to make that move from a monolithic application to a service-based scalable solution. For the field services template, it's available in Get It Package Manager right there in the IDE, includes detailed documentation. So definitely install that, take a look at the documentation there. There's a post right there, a blog post that has an overview of it, a deep dive article that you can take a look at, and a YouTube playlist that has setup and configuration, server development, or showing you how this development server works, the admin application overview, a client application overview, and the last one, UI tips and tricks, is a really good one. Definitely, even if you're not going to use this, take a look at that one because it shows how they accomplish some of the really great UI interfaces on it. Creates a really nice, very professional look very easily. So take a look at that and learn a few tips and tricks on how to have better looking user interfaces. And with that, if you're on live, the webinar, we're going to do Q&A now. If you're not on live, you're watching this on YouTube replay, go out to webinar-scalable 2018 and we will post a question log there for you as well.